So I was a bit wondering what I would talk to you about, because I'm not very active in the healthcare field yet. I decided I would maybe more just explain as a complementary to what I presented yesterday, which was the research direction of Hugging Face. I'll explain more about maybe the tools and the product we have, what we do maybe in more practical way, and that might be the source of ideas for you on how this could be useful, the tools we are building for healthcare, and basically what you are doing. So this is a complement to yesterday's talk, and you will have, after this, I would say, an overview of everything, almost everything that Hugging Face is doing. So you're lucky to be in part 2. So Hugging Face has this science team, and the other big team of Hugging Face is the open source and product team. So the general goal of our company is to build ML in what we call responsible ML, which is actually open and collaborative ML. The history of Hugging Face, at least the recent history, is quite strongly tied to a strong breakthrough in machine learning, I would say, a recent breakthrough, which is now already 5 years old, actually, Transformer, which is ages in today's science life, which is the Transformer, basically, architecture. This led to a Cambrian explosion, they call of pre-trained models. So it's basically the combination of a new architecture that was quite interesting to train at scale, that was much more compute efficient, and also that had this kind of nice feature that it could handle very well long-range dependency, and that this actually exists in many fields, including NLP. So this led to actually pre-training models on very large data sets efficiently, and then the new idea of sharing this pre-trained model as kind of a common resource to build future models. So GPT was maybe the first one that was trained on a significant amount of data that today look very small in comparison to what we do, but still was very the first stepping stone. And this led to then maybe the most famous is the BERT model from Google, which is still used kind of as a generic baseline, I would say. And this like huge explosion of architectural variant in the training data and all these things. The general idea, which has kind of led to this breakthrough in NLP, is this idea of transfer learning, which I think is a very general idea. So maybe the transformer won't be the final architecture that we use for everything, but at least transfer learning, I think, is really here to stay. That's a very fundamental concept. And the idea is that before that, when we were to tackle a problem, we would gather like all the data relevant for us on our specific domain of interest, and we train a model from scratch usually, right? And when we had to tackle a second task, maybe slightly different, or a second domain, we'll do this process again. We gather a data set as big as we can on our specific domain of interest, and then train a model from scratch. And the idea of transfer learning is that actually maybe instead of doing these steps separate, you can gather them. So either group all the data in one very large data set of pre-training, or start from a model that would be trained on the largest data set possible and adapt it to your task of interest. So the idea is that basically tasks might inform each other. And knowing about, if I talk about NLP for instance, knowing about English, the English language in general might be something that could be useful for any task in English actually, regardless of your domain of interest. So it existed already in computer vision, for instance. Transfer learning was quite widely used, and the idea would be that you pre-train the core of your model, and that you fine-tune the last layers for some classification task. But it was really extended very, very strongly in NLP with this idea that this first pre-training should be scaled as much as possible, should be scaled to the largest corpus possible, the largest compute possible, the largest days of training, I would say. And you end up with kind of a intermediate, what we call pre-trained language model, which is trained on generic objectives. So normally it's not exactly what you want to use at the end, but this is a very useful artifact, a very useful resource that you can specialize on many specific tasks with like smaller data sets, even few shots, or now we're even doing zero shot where you actually don't even have a data set, but you have a way to adapt your model. And this step is very compute efficient because you amortize a lot of the compute in this big first step. And this really makes sense if this artifact is kind of shared and reused. Otherwise, it's just, it makes a lot less sense. This has been then extended to other modalities. So it's really started in NLP, where basically the largest data set are maybe the easiest to get because you can just scrap the internet basically, or like download Wikipedia or things like that. And recently it was extended to vision and combination of multimodality that I was talking about yesterday. So I think this is still work in progress, and here the challenge is, and that's kind of a ever coming challenge in deep learning, which is to get a data set which is big enough to pre-train this model. But the preliminary thing is that this work also for vision, for video, and this type of modality. And with this, we've seen the extension of basically transfer learning and transformers to much more diversity of fields. So it started really with NLP, speech, like now pre-trained models of speech are also the state-of-the-art models. In vision transformer, pre-training on very large vision data set is something that will be the trend of this year, was the trend of last year. And we see that also started to extend in biochemistry, time series, and even reinforcement learning, where there is a couple of additional challenges in terms of how you align various type of inputs, modalities, to get a model that you can reuse. That's, I think, very interesting challenges. And yeah, for now, there is still no really limit to this extension of the principle, I would say. Now the question is, this is very research-oriented, so how do you bring that to industry or more practical cases? So the first thing would be to have access to the code and use that. And that's the first thing that we tackled with Hugging Face now 3 years ago. And what you see is that even if the code is usually quite easy to get access to, there's still a couple of weird questions. So the first one is that this code is usually research code. So you have typically problem when you want to use that in certifiable framework, for instance, workflow. Can be Python 2, or it can be just research code that's very, very complex to use. You have various API. And basically for each of these models here that was talking about, this Cambrian explosion, you will see a separate code base, separate API, maybe separate bugs that you will need to discover when you use them. And so that was a bit the situation where we started to do our open source work in the beginning of the end of 2018, beginning of 2019. And we thought maybe there's a way we could do better as a community that would help a lot, both research and both transfer from research to application. And this has been the basic of thinking about the Hugging Face Hub. And generally, the general idea of the Hugging Face Hub is that for a couple of things, including models, data sets, and also demo, I will talk about that later, it could be very interesting if we kind of standardize some API over this model so that people could compare them very easily, share them very easily. And this has led to our two main libraries, the transformer library and the datasets library that are connected to this hub. So let me show you a little bit. This is the model hub today of Hugging Face. So it's basically a Git server. It's a collection of Git repository where you can have access to all these pre-trained models. So today we have about 35,000 public models. They arrange, they can be used for a lot of different tasks. So some of them, so field mask is like a pre-training task. So it's a very generic task for generically pre-trained models. But some of them are also shared when they have been adapted to a specific task, like question answering. A lot of these tasks here are still kind of around NLP, but we also start to have models for like more vision or audio, and also models which are in various type of library like PyTorch, TensorFlow, JAX. We also cover a number of languages in NLP, and this is a bit how it looks. So this is typical GPT-2. The idea is that you share basically all the files. Some of them are config files, some of them are like model files or model weights. And with this, yeah, this was, I think, probably a video. I don't know if you can click on it to try to activate it. With this, we try to promote also a lot of good practices around model cards. So all these models, they come with a long card that is a templated thing around what are the use and the limitations. So this one is the example of GPT-2. It goes actually a lot longer. So normally I had a video that can scroll and show you how complex it can be. Yeah, oh yeah, great, thanks. And you have the music I was listening to yesterday when I was doing that. Yeah. And the idea is that this is also very good practices that we've been missing a lot in terms of reproducibility, understanding the limitation, where your model comes from. And this is something we're pushing a lot. Version control is also another very important thing about reproducibility. And here we think the Git workflow is kind of the canonical example of great version control. So we've been very careful about making that work well for big data files like model checkpoints. We're adding a lot of information. The idea is that your model should not just be like a dump of weights on a Dropbox, but it should have a lot of metadata around it. And some of these metadata are like indicating usage, like evaluation results or standardized benchmark. Some of them are maybe more like CO2 emission, more like, I would say, high-level important metrics. TensorBoard hosting indicates how the model was trained, and you can get the training data afterwards. An interactive widget, also a big part of the hub, which is a model. You can really understand how a model behaves only when you play with it. There is this very important thing about, for data set, it means looking yourself at your data and not at average metrics. And for a model, it means trying yourself your model and just not looking just at the averages metric itself themselves. Now we've started to adapt this hub with many other frameworks, so it's also integrated in Keras, if you want. So basically, it's kind of a place to share and to host your model and your data set with many frameworks. So we've been working a lot with Keras recently, but there's a lot of other libraries that have integration. And the usual workflow, if you want to use a model with the hub, would be that you start from a pre-trained model. So this model that was trained on a very large data set. You find one that's going to make sense for you if you're working on English data, some specific domain, you want a model that can cover this domain. Then you take a data set that you can also take from the hub. You fine-tune your model for your task, and once it's fine-tuned, you can even share it again, or upload it on a private repository on the hub as well, if you don't want to share this. Data set models can also be private on the hub if you want. So the dataset hub was the effort that we underwent on just after the model hub, and the same idea was that the situation in dataset is really fragmented. If you want to find a dataset, often you have to really look for this very specific place where people have decided to host it. Sometimes it's on the Dropbox, sometimes it's on GitHub, sometimes it's uploaded Google Drive. It can be a bit everywhere, and it can be very hard to find them. And so we decided that maybe for the same thing, we could gather the data set at some place and also give an API which can help you download and pre-process your data set. So we're not really hosting them. Well, you can host them, but you don't have to. But this data set, when you load them with the data set library, it will basically go on the specific place it's hosted, like query GitHub, Dropbox, Google Drive, and download the data set and format it, and so that in the end for you the process is exactly the same for all these different data sets. And the same way we can have dataset cards where you indicate the limitation of the dataset, how you made it, how you gather the data, and probably we want to also start to have some metrics about dataset, how good they are on various aspects. Today, I think it's the largest hub of ready-to-use datasets. So the main difference with just a collection of lists of datasets is that here it's really something you can use. Basically, you can type in load dataset and the name of the dataset, and it's really downloaded it and prepare it all for you. So it's not just like listing links to where datasets are. It's really a next step. There's more than 3,000 datasets available today. We're covering 450 languages, which is pretty crazy. I mean, a lot of this, like the long tail of this come from, I think, translation of the Bible, so I don't know how useful it is in very, very low resource languages, but still, for a lot of these languages, we have significant resources and significant number of data sets that you can use. As I said, it's a Python library. There's a specific thing to support huge data sets because it's a little bit something that you want to go toward when you're doing transfer learning. For instance, you can load a data set that's 1 terabyte, even if you have like a 10 gigabytes laptop, which is very, very useful. You can even stream data sets. You don't even need to download them to use them. You can stream them live and train your model using streaming. Now, once you've trained your model, you often think you're done, but actually it's usually just the beginning of understanding how it behaves and also maybe trying to convince other people that you've made a model that's interesting, that you made a model that should be used. And the process can be quite frustrating to try to convince people that your model is working well. And generally, the way we think this could be done is through like demos, through this interactive process of using your model live. So it has several aspects that I think are nice. One is that it's easy to present to a wide audience. The other one is like really reproducibility. Being able to test live the model without having to set up a complex evaluation pipeline just to like really show how your model behaves on a couple of selected examples. And you can identify and debug failure points. And typically when you want to try a model and understand how it behaves, you will want to try it on a specific, really human designed set of inputs that you think are maybe edge cases, and you would like to know where your model behaves, how your model behaves on these edge cases. And the best here is to be able to just interactively play with your model, just like you would like to interactively explore your data set to really understand how it is made. And so traditionally, when you want to use a model, it can be very complex, at least when you want to make it usable for like non-coder audience, for instance. And for this reason, we've kind of teamed up with Gradio team that led up to us acquiring actually Gradio. And the idea of Gradio is that once you have a model that's trained in transformers, so you have your typical model here, for instance, translation model that you load from transformer, you can just with another one-liner basically launch like a human design interface to play with the model. Oh, I think my screenshot is a bit hard to read. But basically, if you run this code here, you load a translation model from English to Spanish, and you design a little bit, you define a couple of things about the interface you want, the title, basically, and this will start run a web page or like an inliner on the Jupyter notebook, where you can put input, submit, and you get the output of the model. So really non-code interface for this model. And here we leverage the fact that a lot of time, like the format for your inputs and outputs is really predefined by the task you do. So the model can vary, but the input output are always the same. So it's quite easy to define them. So this is something you can run locally or share locally, but you can also upload it and share it more widely, either fully public or private in an organization, the hub. And we have now a lot of spaces. So I just listed yesterday the one that starts with bio, so which are maybe more related to your interest. And these are all kind of this small demo that I was showing before, and that are running basically live on the web. So you don't even have to have a web server basically here. You just put them there. This is one example which is doing named entity recognition. So you put sentence and this like label the entities in your sentence. And this is live on the hub. So this one is a Keras model, for instance. This is a couple of spaces that I think are interesting. This one is a speech to classification. So it inputs some speech samples, audio, and the model classify if you think they are like real human or like robot speech. Oh, sorry, this one is about similar person. It's like person recognition. Are these two persons speaking the same person? This one is like more classical computer vision like detection. This one is like image to image transforming. Well, these are maybe a bit less serious, a bit less product focused thing, but in some fields, it's kind of try to cartoonify your face. And I think I have a last one. This one is a text to image. So basically you can cover a lot of different modalities. This one try to make an image from text. And this is a model from, I think, OpenAI Glide. Yeah. Well, this one is. And here is maybe one that you're more used with, which is segmentation with application here to echocardiograms. So this is the idea behind space. That have, I think, many use cases, basically, and that very easy, the same idea is that they're very easy to manage and to set up. And so there is kind of a commonality across all the things I've showed you that we do, which are basically these models, these data sets, and these demo spaces. I mean, all of them are kind of Git-based repositories, so there's this notion of commit, versioning, and like having a clear trace of what happened when you created these various things. They're already optimized for machine learning workflow. For instance, GitHub is nice for coding, but a lot of things are missing when you really want to use it for machine learning workflow. And they're all kind of integrated in the ML ecosystem of libraries, frameworks, and all these things. And these are really our guiding principles when we design all these tools. So yeah, that's a quick coverage of everything we do on the open source and the product side. And if you have any question or remark or ideas about how this could be improved or more adapted, I'm very happy to hear about them.